This is our this is part of the Earth Day celebration that the town holds every year, and this is the one of the educational portions of that. And with us tonight is Alex Moore, who is a professor of environmental health at Long Island University and also a group leader for the Revolutionary Climate and Health Collaborative at Harvard. He's a renowned climatologist, and he's here to give us an update on the health of the planet. With us tonight is Connie Afshar, who's the co-chair of the Open Space and Recreation Committee. I'm Peter Pescatore, former committee member. And this whole thing is being sponsored by the town of Cohasset, the Chamber of Commerce of Cohasset, and the Open Space and Recreation Committee. With that, we're going to turn the presentation over to Alex.
Thank you, Peter. It's great to be here tonight. I've done this, I think, a few years ago.
Yes, you did.
It was great to join you all in Cohasset. As you might know already, for those of you who are my neighbors, I live in Hall. I do work at Long Island University in New York City, but I actually spend more than half of the year in Hall between summers, winters, and pretty much every weekend I can manage. So I care very much about this area. Perhaps we can start with something that's familiar to everyone: the impact of climate change that is happening all around us all the time, and that is how temperature has warmed in the Northeast, particularly much more than the rest of the country. And this map you will see from Climate Change Institute at the University of Maine, where I also am affiliated. You'll see how much warmer it has become in the northeastern United States compared to the rest of the country. And if you map on top of this the cases of Lyme disease, there is almost a one-to-one correlation. You can actually draw a line at the 3-degree increase right around the cases. And this is not accidental. It's because ticks reproduce during the fall, and we have doubled the length of the summer effectively in the last 20 years due to man-made climate change. Recently, I collaborated with a local magazine in the Adirondacks, Adirondack Explorer, to see how that has affected that particular state park, one of the best, most protected state parks in the United States. And this is how cases of Lyme disease have encroached on the park in the last 20 years. It makes life there rather difficult, and makes life very difficult in our backyard as well.
Down, bring volumes down.
I don't care, Jack.
You don't care about whether it rings or anything? You don't care whether it rings?
Hang on, there's a little bit of interference on the call, so I'm just gonna perhaps, oh, there you go, great. So in New Hampshire, as I was mentioning, there is this problem has affected the deer and the moose population, with particularly the moose having as many as 40,000 ticks on them, which basically bleeds them to death. And you have this phenomenon known as ghost moose, where the calves don't even reach adulthood; they just die. Sometimes they're infected with Lyme disease, and this is the direct result of the ticks reproducing, but also loss of biodiversity. My previous talk at Cohasset was, in fact, about biodiversity loss, but we talked more about the ocean. In this case, we're talking about loss of biodiversity in the Northeast, due to us, again, not only encroaching on the wildlife and their habitat, but also removing top predators like wolves, which used to call particularly the deer population and deprive the ticks of so much food. Why is this important? Why am I talking about disease? I'm talking about disease because we just came out of a pandemic, because I am an environmental health professor, and because it is the most important way that we can really motivate people to act on climate. And I want to tell you a story about how climate has affected health over time and how it will affect it in the future. If you think about time as a line, and we're there, and there is no year zero, so let's talk about the last 2021 years. We can break it up into a warmer period and a colder period, and a warmer period and a colder period, and then a really hot period, which is when we've been living for the last century or so. Interestingly, pandemics have emerged as a transition periods between these colder and hotter periods. The previous ones you see here, the changes from warm to colder occurred because of natural changes in the earth, such as volcanic eruptions, which can block sunlight and lower the temperature of the earth for quite a few years, sometimes centuries. And when that activity stops, the earth warms again. And then when the volcanic activity returns, you have colder period again. There are other things that influence the temperature, natural temperature of the earth, solar cycles, for example. But these are not century-long things. They're usually shorter. It is undoubtedly, it's at this point accepted by 98% of scientists for the last 150 years. We've been warming the planet by emitting greenhouse gases, CO2 particularly, carbon dioxide, but also methane. And in the last 200 years, we've had many pandemics, particularly of cholera at the transition to the 1800s, the Spanish flu, the greatest pandemic ever to ravage the world by number of dead. 50 million died. And with COVID, even with the revised estimates from India, we're still below 10 million. And of course, the 2012 SARS, and then later also the COVID pandemic. Pandemics have historically started during periods of climate instability, and we are in the most unstable climate that we have ever seen, not only in historical records, in written records, but also in the natural records going back about 4,000, 5,000 years. How do we know this? We know it because obviously we don't have people telling us that 5,000 years ago the climate was unstable. We know this from natural records. The gold standard of climate science, the way that we know about the past, how climate was before now, is ice cores. And my team and I have worked with ice cores for now more than 10 years, and they, before me, at the Climate Change Institute for 2 more decades before that. And the Climate Change Institute is really the best place in the world to do this. They have pioneered new methods to analyze ice cores and create the highest resolution climate records on the planet. Climate records that can tell you what the climate was like 2,000 years ago on Christmas Day, if you were interested. No other institute in the world can do that. We have used this record, particularly one from that I've been working on, with a 72-meter core, about a 210 feet core, to study the pollution and climate change for the last millennium, and compare it to the present so that we can understand how bad things are now. An ice core captures everything that's in the atmosphere simply because whatever pollution we put in the atmosphere, whatever ash or other chemicals may evaporate into the atmosphere, those chemicals fall back onto glaciers and get captured in ice, just like you would in amber. If you remember Jurassic Park, the mosquito in amber that captures a time capsule of DNA, that's very similar for climate science. So to give you an idea of what this involves, I'll give you a short introduction. We organized an expedition to the Western Alps in Italy and Switzerland, right on the border, on the second tallest mountain called Monte Rosa, at the foot of this hill here, where this hut is the tallest, not the highest, not tallest building in Europe. It's called the Margherita Hut, after Queen Margaret of Italy, the same woman that gave the name to the pizza, which is why I call it the Pizza Hut. She was trucked all the way up, actually donkeyed all the way up to this place, and it turns out one of the best places to get an ice core. So we created a dome, and then our team drilled 72 meters into the ice, 210 feet into the ice, and brought this ice back to us in order to be analyzed. The glacier is shrinking like all other glaciers, and so we had to figure out a way to maintain the ice for the future, because we're losing a record of climate change because of climate change, despite the storm that you're seeing here, where people are trying to, get back into the dome to do work. And these are the conditions of climate scientists, field scientists. The ice is actually shrinking on this glacier. We're losing the record. And once we lose it, we can't regain it because all the time capsule is gone. So we brought it back to Maine and reconstructed how wind patterns blow over Europe to understand where the pollution comes from, where gases come from, and understand also the circulation of the wind over Europe to understand what's going on in the past. If you don't do this, you're basically blind. You don't know what's going on. And then in order to preserve the ice instead of melting it entirely, our team created a laser system that ablates, it just melts just a little bit right at the top of the ice and in a vacuum. And then that, you can see the groove of the laser. That ice then goes into a mass spectrometer and gives us the chemical concentration of pollution and climate indicators. This data showed us that during the last great pandemic, the Spanish flu, the greatest pandemic by number of dead in the history of man, we had spikes in deaths every time there was an influx of cold, wet air over Europe. And this cold, wet air had been was arriving over the continent at a level unprecedented in the period between 1915 and 1920, which is also the period of Great War, World War I. We know this from also a reanalysis map, which I created, a climate reanalyzer, again, a tool of the Climate Change Institute. You can see this enormous low pressure system. That means cold, wet air over Europe, right in September of 1918, when the Spanish flu started, the second wave of the Spanish flu, the most deadly wave of the Spanish flu started. And that's where our ice core is. We know that this was the case because if you've studied World War I in school, you know that all the battlefields were flooded constantly. People lived in water constantly. And we wondered what could have caused an anomaly like this. And it turns out that what you're looking at here is the fields of Belgium, the fields of Flanders, which were these pockmarks you see were bombs. These fields were bombed for the first time in history to a level unprecedented. And the dust that was created by this constant bombing ended up in the air. And dust works, interestingly, like little magnets for water vapor that's already in the air. And it basically, I don't want to say coagulates, but actually condenses these little droplets into big drops, and you have precipitation, you have rain. This is how people make it rain today. The Chinese have really mastered this art of artificial rain. And we did it inadvertently during World War I. And we continued doing it for the entire duration of the conflict. And as I said, people were exposed to this weather, hot and cold, wet weather for 4 or 5 years. Their immune systems were severely affected. Your immune system actually does react to the weather conditions. Grandma was not wrong when she told you to, get a coat on and cover your face, because otherwise you're going to get a cold. It's not that you actually get the cold from the air. It's that your immune system exposed to the elements becomes weaker, and therefore whatever virus you may have already picked up can't overtake your body. And that's exactly what happened to many soldiers in the trenches with staphylococcus infections and all sorts of other infections of the lungs, bacterial, and eventually also viral. The viral infection that they were exposed to was transmitted by birds, particularly mallard ducks, which are the greatest carrier of H1N1, which is the Spanish flu, the Spanish influenza. In autumn, in September, October, when the second wave of the pandemic started, these birds reach a 60% infection rate. 60% of them are infected with it, and their droppings infect the water for 2 weeks. So you have a perfect storm, no pun intended, of a cold front with the rain that is constantly dropping onto the battlefields of Europe, high concentration of people. The water is overflowing and mixing the contaminated water with from these vectors, from these birds, with the water in the trenches, drinking water, and the low pressure system, the climate anomaly that we created, also interrupted their migration. So you have also high concentration of the birds that carry the disease, the vectors of the disease, and this exploded into the Spanish flu. So what we noticed was that if you look at the precipitation, that is rain over time, over the 5 years before the second wave of the Spanish flu, and then you look at how many dead there were, you see, again, a very, very close correlation, particularly in the second wave of the Spanish flu, which you can see here is a telltale double peak of dead in the autumn of 1918. And that was the smoking gun that really showed that we were looking at a pandemic that had been at least enhanced, if not caused, by our impact on the environment, by bombing, by our impact on the climate. So just to give you an idea, these are actually for COVID are somewhat old numbers, but the Spanish flu pandemic killed 50 million people. It infected 500 million, which was a third of the world population. Most likely it actually infected everybody. About 2/3 were immune, because when 1 out of 3 people get it, it means everybody has it. By comparison, COVID actually has killed about 6 million. Some say 10 with renewed figures from India. And what has had it's reached about 200 million people, has impacted 200 million people, but not even close to the impact of the Spanish flu. Of course, every one of the COVID victims is someone to somebody, and that doesn't diminish their loss. But this is just to tell you the impact of this pandemic. We published this article. It is in the top 5% of all research ever published, and it has received worldwide press attention. And of course, the Audubon Society published a very similar article in the same week, perhaps taking a cue from ours, telling us about how we may, in fact, predict future pandemics. And this is the whole point of tonight. How will climate affect pandemics, and how can we predict future threats like this? Climate change will not only change our environment in terms of, not being able to be outside as much because of mosquitoes or ticks or the temperature being too high, but it will also change the disease environment around us and how people will be infected by disease. And the reason for that is that climate changes migrations of all vectors of disease. All disease vectors are usually animal or insect, and they are happening all around you all the time. We may not notice it, but that's what's happening around us all the time. Animals are migrating, and mosquitoes and other insects are migrating. And climate changes that. Animals migrate because of temperature, because of food availability that is related to changes in the seasons. Right now, we are in bird migration season. And if you're in New York City or in Massachusetts, you can really notice it because you'll see lots of birds that you normally don't see around you. This kind of movement of animals and carriers of disease is happening around us all the time, both North and South America, around Europe, particularly in places that have higher biodiversity, higher mass of animals. And this is important because in the last 2,000 years, new epidemics have emerged when people change the environment by deforestation, by reduction of wildlife habitat, by animal domestication, wildlife trade, and man-made climate change. And the epidemics that came from all of that are diseases that we know very well. AIDS, Zika, the Spanish flu, Ebola, dengue, chikungunya, Lyme. All of these are diseases that come from animals, including COVID-19. And the movement of those animals means that the movement of disease. And these are just the diseases we know. Ebola, AIDS are diseases, for example, that came, and COVID that came from the wild that we had never seen before. And those are really the scary ones. Those are the difficult ones to fight because we have no drugs for them. We have no vaccines for them. It took us more than a year to find a vaccine for COVID. And it was almost a miracle that we could do that. Imagine having a disease as infectious as COVID-19, but as difficult to vaccinate against as AIDS. That would be a very difficult problem to solve. And that's why we need a completely different system for trying drugs and trying vaccines compared to the one that we have right now. And I just actually am about to publish an article on that in Nature Medicine. But the single best thing that we can do to prevent the next pandemic right now is to ban wildlife trade worldwide. Right now, this is an easy thing. It's not a large business. It only satisfies an elite market, and it is the most dangerous thing we're doing, and we're trading. Because if you take animals from the wild, you will take diseases from the wild too. So rhino horn and bats and all sorts of civet cats for coffee, or you name it, exotic feathers, all sorts of very common animals, products that are sold on the legal and illegal market. The legal market is actually quite large, should be banned right away. So that's one take-home point if you don't remember anything else from tonight. Second take-home point is that this climate change is affecting the way that diseases spread. Two mosquitoes, whose name in Latin I'm not going to bore you with, that carry dengue fever, chikungunya, and Zika, used to be only tropical mosquitoes, but their range now extends all the way to New York City, and eventually they'll likely reach Massachusetts. This is the extent of the same two mosquitoes that carry, again, Zika, dengue, and chikungunya around the world. Because of climate change, their habitat is extending to modern Europe, to developed countries in Europe, to basically most of Africa, where people have high density population, all throughout Southeast Asia, which is the highest density and highest growing area of the world in terms of population, and of course, South America, where it's already endemic. The malaria spread also with Anopheles mosquito is following the same pattern. This is currently the number of months in which Anopheles mosquito that carries malaria can live in these different areas of the world. We are only 1 or 2 months at the moment, but by the year 2080, we'll likely reach 3 to 4 months that we can have malaria in our environment. And if you think that this is not a concern, malaria is actually the largest pandemic currently going on in the world. It kills hundreds of thousands of people every year. If you have ever visited tropical areas or sub-Saharan Africa or the Amazon, you know that you have to be very, very careful about how you sleep, what medicines you carry with you to avoid infection. So this is actually a threat to our health. And again, this is the second point to remember: climate change is health. There is no point, there is no question about this. And we change climate and nature, and therefore we change health. And we are basically making our health worse. Protecting nature means protecting us. So when people say act on climate now, we're not really talking about buying a Tesla. We're talking about actually lobbying Congress to phase out practices and consumption levels that are taking us irreversibly toward a point of no return, where our environment is going to change and our health is going to change as a result of it. One thing, for example, that many aren't particularly aware of is that, although I think you all must have heard in the news that the Arctic and now Antarctic are warming faster than any other place on Earth. We actually doubled the length of the summer in the Arctic in the last 20 years. It's abrupt climate change. The Climate Change Institute discovered it about 20 years ago. This is having an effect on permafrost, that is frozen ground in the northern part of the world. The largest permafrost largest areas of permafrost are in northern Russia here, and also in Canada and Alaska. So these areas are warming very, very quickly due to climate change, man-made climate change. And permafrost contains methane, which you saw here, these bubbles they're actually frozen in the ground, and also in lakes that are permanently frozen. They look like this. They're quite beautiful. Methane is 70 times worse as a greenhouse gas, as a warming gas, than CO2 for the first 20 years that it is emitted. So we are actually now warming the planet in its most sensitive parts, where that is causing a avalanche effect, if you will, where or a domino effect, where the most sensitive gases are being expelled from these areas, and those gases are warming the planet even more. So this is why this is urgent, and why we shouldn't simply, again, feel satisfied by policies that seem to address climate change with, more consumerist luxury emission, if you will, approaches to climate. So, again, buying a Tesla is not going to solve this problem. Solar panels may contribute, but they're not going to solve this problem. We're talking about massive scale of emissions that need to be stopped. We are all on the shores of the ocean in Cohasset and Hull, and I'm a big fan of the ocean. I've loved the ocean all my life, and the ocean is also changing. Not many people know cholera, a disease, a bacterial disease that has killed probably millions of people in the last 200 years, lives in the ocean, lives in coastal waters. And the temperatures in the future climate models that we are expecting in a future, the current trajectory in which we are show that the increase in cholera will be substantial. And we don't need the models to see this. You can simply see this in the temperature of the oceans. In the last 50 years, the ocean has basically made us, allowed us to survive, because most of the heat trapped in the Earth's climate system due to greenhouse gases is actually ending up in the ocean. So if you think about all the heat that's in the Earth's climate system, that little sliver of white there is how much heat goes into ice, melting ice, glaciers, and ice sheets. And that little sliver of brown is how much heat is absorbed by the Earth, like permafrost. And that little sliver of purple is how much heat is absorbed by the atmosphere. When you go out in the morning and say, oh my God, today is really hot and it's only April, that's what you're feeling. It's that purple. This is how much heat is absorbed by the deep ocean. And this is how much heat is absorbed by the upper ocean, where the ocean that we all see and live and sail and swim in. The upper ocean, the upper 200 meters, 600 feet, absorbs 63% of all the heat in the Earth's climate system, and it has increased exponentially since the 1970s. And the deeper ocean is absorbing 31%. And that the rest there is 6%, and that's where we live. So when we think that our environment where we live in is, getting too hot for living, we need more air conditioners, that climate change is really affecting us, think about what's happening in the ocean. It's 30 times worse. And that's why we're seeing such changes, such drastic changes in the wildlife. One of the changes that we've seen on our shores often, but that goes unremarked and unreported, is the increase in this algae here, which I mentioned, I think, the last time we had this talk. A red algae called Heterosiphonia japonica, which is invasive and comes from the Sea of Japan. It came in spores, most likely on the hulls of ships that come from Asia and wash their tanks, perhaps at sea, or simply the spores get stuck to the hull of these ships and then they come to our shores and those spores are released. And in our oceans, they find the very best, most ideal circumstances for surviving because we have warmed the ocean so much. Last year, I remember jumping into the bay with my friends, and the temperature of the water, I think, had reached 75 degrees, which is unheard of. I've lived in Hull for 10 years almost, and that 10 years ago, the water never reached 75 degrees. So this is how much that will impact the viability of the water for diseases like cholera, which live in the ocean. We're still in better shape than the tropical areas, but it's not going to be as unusual as it used to be. And particularly this is in the Caribbean, where we see this really spiking, and in combination with hurricanes, it's really creating a health crisis. When hurricanes, oops, there's something wrong with the slide. When hurricanes come along, you don't have to have sea level rise for these changes in the ocean to actually affect health or affect people. Because when the hurricanes come along, as you all know, living on the ocean, you have a storm surge. That storm surge brings water over the coastal areas and seeps into the freshwater lens, which is where we take our water, our drinking water, and when it seeps into the aquifers, the water reserves that we drink, we may have contamination of that water. Not only is it saltier, but it also may carry diseases that are in the ocean already, such as cholera. And cholera really grows in the summer months from May to October. Now the summer has doubled, so that's the length of the summer. And the cases of cholera have been rising quite steadily over the last 20 years. So this is a significant problem. You can see here the difference between 2013 and 2018. And we had about 43 cases in 2013. Massachusetts in 2018, we had almost double, 79. So this is not an unusual. Yes, it's a bacterial disease. Yes, we have antibiotics for it, but it is also a very fast disease, and it's certainly not something you want to deal with as a routine. And of course, the warming oceans are affecting our food supply. Many of us are aware of the declining cod population in our shores. I took this video. There actually is cod in our waters, but not as much as there used to be. This is due to the fact that it has migrated. There's lots of other fish there that's growing. Squid, for example, are going to do much better with climate change. Not all species suffer. And of course, the environment out there is gorgeous, as beautiful as it is on land. I'm a big fan of diving around our shores. I encourage everyone to be passionate about it and visit the underwater world. You'll see things like this adorable pufferfish, but you'll also see things like these invasive seaweeds, particularly this red seaweed, which covers everything by the middle of the summer and suffocates wildlife that lives on the bottom of the ocean, reaching as much as 3 feet of thickness all throughout our coasts, and then eventually landing on our shores. This is Sandy Beach in July of 2017. People may notice it, may be bothered by it for a month, may complain about it, may want, that we may have petitions about cleaning it up, but we're not asking the questions of why is this happening and how do we stop it? And the why is climate change and how do we stop it is, I don't know, because there's nothing that eats this stuff. It affects, all of these things affect marine wildlife. This is also Cohasset a few years ago. And on the Jerusalem Road right in front of it was, I think, this is a calf of humpback whale. So we have many unusual mortality events due to changes in the ocean all throughout the East Coast. And we think many of these are due to diseases that are now blooming in the ocean. They're becoming more common in the ocean. Diseases don't just exist in the air and our environment, they exist in the ocean as well. And they affect they affect wildlife like this. Unusual mortality events are being documented all throughout the East Coast, as you can see here. And as I said, many animals are migrating because of the warming ocean. The Gulf of Maine, according to my colleague Andy Pershing, has warmed faster than 99% of all other bodies of water in the world in the last 35 years. This article was published in Science in 2015. It's still the best there is. And we think that the effects on this on cod have been catastrophic. Cod is seeking colder waters, just like birds migrate in order to follow the warm temperatures or the right temperatures, so do other ocean animals migrate in order to find the right temperatures. Most animals have evolved within 1 or 2 degrees range of a certain temperature, particularly in the ocean. The deeper you go, the more precise that temperature is. Imagine growing up and with no clothes, nothing else, and wouldn't you want to stay in at the same temperature that is ideal for your life, for your skin, that's what animals are doing all the time, not only on land but also in the ocean. And so as a result, they're migrating outside of our waters, and as a result, we are not fishing them anymore. This is the article if you all are interested. And climate change is affecting our food supply in other ways. You all must be familiar at this point, if you watch the news, with the enormous wildfire problem that California and the West are having. Besides polluting the air and making it almost impossible to breathe between March and November, and on the West Coast, wildfires threaten our food supply. 40% of our fruit and nuts are in the Central Valley of California, which you can see here in this infographic I created with my students. And the red, the fires surround that area. So we have 40% of our fruits and vegetables surrounded by a ring of fire due to climate change, and also due to the inappropriate lifestyle of Californians who decide to, or people who buy houses in California and decide to live in the forests around this area, make it impossible for controlled fires to actually control the amount of fuel that is available. And so the more these fires are put out, the more the big wildfires are going to become devastating. And that's due again to our mismanagement of nature. This area, by the way, is the driest area in the world, in the United States at the moment. It has undergone 15 now, almost 20-year drought. and it is 75% of it is irrigated. That is, water needs to be brought in order for it to be fertile, in order to grow 250 crops worth of 17 billion per year in the economy. It is unsustainable. It is the epitome of unsustainable, and it was a bad idea at the moment that it was started. We have plenty of land in the middle of the country that is in fact fertile and receives rain that is fairly reliable, and we don't use that land in Iowa or Ohio or Illinois or Missouri or Kansas for fruit and vegetables. We use it to grow vegetables that are given to pigs and cattle. 95% of corn produced in those areas goes to feed cattle. It does not feed humans. 5% of corn goes to humans. The rest goes to cattle and ethanol. All very subsidized by your tax dollars, by the way. And just to give you an idea of how this is mismanaged, and this is also climate change because it's these are the highest carbon footprint foods on the planet. All that water that could be used for growing food, actual plants that are low carbon and are high nutrition value, is actually going toward beef and pork and lamb and soy, which are high water intensive foods. And the last thing is the most immediate thing, I suppose, temperature. How is temperature going to change our lives? We think the colors here show you how many days a year are going to be above 90 degrees Fahrenheit, which is not a temperature that humans can really survive for more than a few hours. So this is how many days. In the darker it gets, the more days that these areas are going to experience 90 degrees and above temperatures in the scenario that we're going to reach in 50 to 80 years. Massachusetts, we're doing okay. That's why I moved there when I immigrated to the United States. But Florida is a goner. Florida is basically air-conditioned land, and so is Texas. So is most of the South. And these areas in the Southwest are only lighter because many of them are higher in altitude. But even Illinois and Missouri and our farmland essentially is going to have 50 to 60 days above 90 degrees. What's that going to do to our food? What's that going to do to farmers? What's that going to do to populations? Populations are going to start moving. They're going to have way more danger days, days above 105, where people can actually have a heat stroke by just walking outside. Miami, this is what we are expecting. More than half a year is going to be above 105. There are a ton of people in Florida. It's the most populous, one of the most populous states in the country. And the Northeast is also going to get hit fairly significantly, but not as significantly as the Southeast. And the death rate due to heat stroke is going up, particularly for people with an underlying disease. This is because we have changed the climate and we've changed the average temperature of the entire globe, but particularly we've increased the temperature in northern areas where people live. Most people in the world live in the northern hemisphere. There are very few people south of the equator. And the northern hemisphere is heating up faster than the southern part of the world. And the change in average, when you hear 1 degree, 2 degree average increase by the end of the century, doesn't sound like a lot, right? And you have to think that when you're talking about an average, you're talking about an average of all temperatures in the northern hemisphere throughout all years, throughout all the days of a year, and throughout all the geography of that place. And temperatures are different. They're, the average is not all places have the same temperature. Portland, Maine is a different temperature from Chicago, Illinois is a different temperature from Los Angeles. And the fact that we can move this average, that if you divide things up, right, if you create averages of a large number of places, it's really hard to move that average. The fact that we've been able to move it 1 degree or a degree and a half, or that we will be moving it by 2 degrees by the end of the century is catastrophic. Another way to think about this is if you ever had a D in, if you had a couple of bad grades in school, in college perhaps, and you wanted to move that grade point average back up, how hard was that? Well, that's how hard it is to move an average, and we've done it. That's how really severe this problem is. And we are doing some things to overcome this. And we hear the word sustainability thrown around a lot, along with all the other ones that you see on that screen: green transition, mitigation, co-benefits, environmental impact, ecosystem services, all these words that are thrown around and by businesses and government, and they all fall under the umbrella of sustainability. There are lots of jobs in sustainability now. There are lots of businesses that are selling sustainability, but sustainability can't be just another word for us to keep using to do the wrong thing. It's not a question of simply, again, buying a Tesla or changing, turning off the lights at night. The scale of change that needs to happen is a reduction in consumption. We are extremely wasteful in our lifestyles and in the number of people that are consuming energy. And that needs to change. And we haven't come to grips with that. Some people have said as much. They're usually ignored. Climate scientists have been screaming it for 30 years. A Massachusetts scientist, Donella Meadows, created a whole new science called systems dynamics to understand this problem in the 1970s, and she was right on the money with every single prediction she made at MIT. Systems dynamics is how we now predict not only energy consumption, but how pandemics will occur as a result of climate change. What I just showed you, the combination of all of this data together, that's systems dynamics. And that's the future of science. It's interdisciplinary, and it takes people and teams of people from all walks of life to actually understand, to recreate at least part of nature. But this doesn't mean that we will actually understand nature the way that we should, fully understand nature, because nature is extremely complex, and our hubris, our arrogance, to think that we could dominate nature and make it serve us, which continues in most approaches to economics, to trade, to policy. That hubris needs to go away. We need to live with nature. We need to understand nature as a right to live, to exist. And if we take care of nature, we'll take care of the entire house. That's what ecosystem comes from. Oikos in Greek means house. We take care of the entire house, then the house will take care. I'll end with this figure. We're still in Zoom. We're still separated from each other. It turns out during the pandemic, people didn't go anywhere anymore. They definitely didn't go to workplaces. This is a graph of where people went once the pandemic hit in March and April of 2020. They didn't go to workplaces. They didn't go to retail. Barely went to food stores. They stayed home. But the one place they did go was nature. And I'm sure that those who are here tonight and anyone who's watching this on television later on will agree that if we had not had nature and green spaces around us that we so love, and the blue spaces around us too, for us who live on the shore, we would have had a very hard time getting through this crisis. This is a graph of how important that is in our life. And I created one of my pet projects during the pandemic was to create maps of green spaces around where biodiversity is, so that I could make myself some missions every day to go see something new, something different in nature, and photograph it. And occasionally I do that, and I really enjoy it. And this is data that's available to everyone, but I just put it on a map where the highest concentration of biodiversity is in Massachusetts. And it's right around us, all around us. And, you know, this has to be the highest concentration of parks I've ever seen anywhere else. I grew up in Europe, where there were no national parks. So there were very few in Italy, particularly, and there were very, very few green spaces and city parks. Look at what we have in our backyard. And, you know, it's conservation societies and conservation trusts, like the ones that you all run, that make this possible. And it's really important and makes a huge difference in people's lives. So this is what I would like to end.
Well, thank you very much. I don't think, well, we're disappointed that we didn't attract more people. We sent a lot of emails to every group in town and get out on social media. I think it was a very challenging presentation. It really wakes you up to the depth, you know, of what's really going on versus what we get fed through our news channels. So it's very refreshing. Thank you. Much appreciated.
I mean, one of the things that I think I'm most frustrated about as a climate scientist, as many of us are, is that that what you do get fed over the news is a very simplified version of the science that's back, you know, 30 years old. The IPCC, hey Vince, good to see you. The IPCC, the International Panel on Climate Change, UN's Committee on Climate Change, if you've ever had a committee, you all know how committees work. You know, when you have to agree on something and what's going on, it's whatever everybody can agree on, which is, you know, whatever makes everybody unhappy. It's the most conservative possible outcome. But people like us who actually do the science and look at this every day realize really the extremes to which we have arrived in climate change.
Questions? Anybody? You've all been elevated to panelists, so you can ask your questions. You need to unmute.
If I can jump in for a second. A great presentation, by the way, Alex. Thank you very much. So you were talking about how what we can't do, and I realize that small things are individually not necessarily meaningful in the grand scheme. On the other hand, in a town of our size, and even Hull, where I happen to live as well, we're not going to stop, you know, global warming all by ourselves, but we can take action. So what kind of, we understand the problem is much bigger than all this, but what are the things we can do concretely at the local level, besides advocating and lobbying and all of those things, to help improve our own environments and our communities' environments to help address these things?
First of all, talking about it is a good thing. Talking about it is a good thing. consuming less is a good thing too. I do think that, thinking about energy demand reduction is just as important as thinking about how do we continue doing exactly what we've been doing with the same amount of energy, but different sources. We have to do both. And you all are involved in government. You're involved in advocating for these things. I'm involved in it too in Hall, and I'm involved in it nationally and internationally. So those are important. I think also most of us feel disempowered by it, by the scale of the problem. Right? It's so big. How are we going to do it on a daily basis? And my answer is you vote with your dollars every day. So I wasn't, going after Tesla for any reason particularly. There are lots of now green cars that are coming out. They have their own problems. Lithium is not a very common element, and that needs to be solved. That's a problem that's actually destroying nature in certain places. But you vote with your dollars every day, and if you continue to give dollars to companies that are not doing anything to solve this problem, or are actively misinforming the public, that's a problem. And so, if campaign finance laws, of course, for in order to free our elected officials to actually act on this, as opposed to being slaves to campaign contributions from those companies that are doing so much damage, that's a big deal. I think I've worked in government briefly with Senator Kennedy, and I think anybody who has knows that the biggest problem with the US government today, like the state, local, and national level, particularly the national level, is campaign finance. Citizens United is probably the worst thing that ever happened to the US Constitution for the last 50 years. It basically has disempowered us from electing officials that are going to represent us properly. So I think campaign finance reform is one of the number one things that makes us pass all the other things. Right? It's the one bill that makes us able to have representatives that actually will act courageously politically and will do what we need them to do. So those are the perhaps not common things to think about, but certainly things that we should entertain.
Susie Margaret has a hand up for
Yeah,
question.
sure. Susie?
Can you unmute her? She had her hand up. I guess she took it down.
A couple. What can we do on a local level? Marianne also asked. So again, on the local level, I think, being involved in local government, actually, I think local government is one of the few things that actually works. Susie is unmuted now. Perhaps she can.
Yeah, Susie, did you have a question? I guess not.
Okay.
Any other questions?
Yeah. So just for the heck of it, could you kind of connect the dots from what happened several years ago when the Nepalese went into Haiti to help and somehow or rather brought cholera with them and contributed to the cholera epidemic in Haiti?
I am not familiar with the episode. I know that Haiti has cholera as an endemic disease, has had it for decades. Some of the maps that I showed you were actually Haiti. And I can show you those maps again. What is really interesting and really proves the point, I think, is that if you look at the island, Yeah, so this is, yeah. So this is Haiti, and the particularly this area as an endemic severity of an endemic presence of cholera, and it's also fairly highly populated. And if you look at on the Dominican Republic on the other side of the island, that's not the case. So it's really an infrastructure issue. I don't know if I mean I don't know anything about the Nepalese. I'm sorry. That episode is not known to me, so I'm not gonna.
Yeah, I actually read a bit about that, and I thought it was poor sanitation
Yeah.
that spread it. And the
Yeah,
Nepalese
cholera is
were careless with the sanitation, and that it spread badly.
Cholera is an extremely easily spreadable disease.
Yeah.
Very, very easy to spread.
Hmm.
And you know, you will see that every time we have a hurricane, and that's the other side of the coin, right? Climate change will cause more hurricanes, and hurricanes will create storm surges. The storm surges carry with them the water from the ocean that may have cholera already, or may simply just create an overflow, a contamination of sewer water into fresh water, which is what happens every time there is a hurricane. That's why it happens in areas that have poor infrastructure. Not the hurricane. That's why the epidemics happen in areas with poor infrastructure. There's just that's the system. It has worked that way for as long as we know that cholera has existed. And it's a concern.
Okay. Any other questions for Alex? Well, we have
You
them.
seem to have something. Ginger, you're muted.
I am. Yes, I missed the biodiversity lecture that you gave, but I was curious as to what I'm getting feedback from my husband, who just is in the next room with on a computer. Rich. Oh no, I can't talk because he's got his computer on. I have to turn it off.
We'll see him show up. We'll see him show up with Rich on the other side.
Well, one good thing is a friend of mine. I don't know if you know Erwin Nestorf. Do you know him in Hull?
No.
He's
I
running
do.
for selectman.
Yeah, I know Erwin. Yeah,
Yeah. He's a great guy, and I think
running for selectman at this time.
yeah, in Hull.
Okay, we've got one computer. Sorry about that. We were both listening to you, but then he moved a little closer, and I got feedback. I missed your biodiversity lecture, but obviously you can tell I'm into that. It's certainly into native plants as one way of working on that. I'm sure there's so many different ways.
Definitely.
But I'm wondering if there are any towns near us that that are great models for doing things at the local level that under town government. Because at this time, people are asking, well, what can the selectmen do? There's nothing they can do to help out with climate change. And that's like a discussion. That is a discussion that's going on the local social media. So are there things that local governments can do, and are there models in the state?
There are models. We looked at this with the Hall Green Energy Committee we created about 3 years ago, and pandemic happened. I was taken here to New York to chair the Department of Public Health, and I kind of lost touch. But we did do that, and the people in charge of that committee have done quite a bit of surveying, and I think Steve Wenner was another person who had done that type of research of other cities, and actually another. I have lots of thoughts in my head. Another colleague, another friend who's worked on this is Tom Cotton, was one of my friends who sails with me, and he's not from Cohasset, he's from Harvard, Massachusetts, and he's in the Conservation Society. And what I was alluding to earlier, in terms of parks, I know that it's a kind of an odd place to stop this lecture, but in fact, one of the best things we can do, and at the local level, we have the power to do, is to conserve land.
Yep.
And the more land we conserve, and the more land we rewild with trees and native species, the more
Yep.
carbon we capture. And the
Absolutely.
more we create an environment for us and animals to have a good life.
Yeah.
So I am a huge fan of conservation societies.
Yeah.
And conservation.
Actually is blessed. The Open Space and Recreation Committee has become the stewards of open space. We
Uh-huh.
also have the Cohasset Conservation Trust, which buys up lobbies for, people to bequeath their properties, and, we watch for, they have some funding, and we watch for open space to come up and try to get it.
Yeah.
So, there's also Wild Cohasset, which tries to communicate to the community about the dangers of all of these invasive species that squeeze out the other flora and fauna that feed the butterflies and everybody else. So
Yeah.
we're a little more active, I think, than some of the committees, and it's from the efforts of those kinds of committees.
It's
Is there any systemization or coordination amongst those committees, all the people in those committees?
We have our Earth Day celebration on Saturday from 9 to 2:30, and there'll be 5 other groups. The Wild Cohasset will be there. The Alternative Energy Committee will be there. The Coastal Research Group will be there. A couple of others. They're escaping me at the moment. So we do cooperate. We do cooperate and share lists, and and promote what each other are doing to try to get the maximum communication out.
I think conservation trusts. This is the only way. So I've been consulted by multiple. I live in New York City the rest of the time, and I get consulted by sustainability people all the time, and particularly impact investing funds. And they always ask, okay, so if you had $500 million, what would you do? And they think I'm gonna say build a giant carbon capture facility, or
It's called.
I tell them I'll buy land.
Yeah. And Cohasset became a Tree City USA from the lobbying of the Open Space Committee. We also got the town to start recognizing Arbor Day again. They planted some trees last year. I think they're going to plant some trees again this year. So a little bit slowly, you got to start with the smallest step. And
it's vitally important.
Nothing is meaningless.
No, and that is vitally important. I mean, rewilding. Speaking of things that the IPCC gets wrong, we are underestimating the impact of forests, of trees,
right,
on climate enormously.
Well,
they not only capture the CO2, but they not only capture carbon, but they change the climate for the better. They cool the climate, and we still don't understand fully how that happens. But to give you an example that's perhaps infamous, when Columbus reached the West Indies, the Caribbean, he didn't like the climate. You can read this in his nephew's journal. He didn't like the climate of an island. Cut all the trees down, changed the climate of an island. That's we've been changing climate for that long and probably
Yeah.
longer. And trees are the number one way that we've been doing that. So let's plant some trees and
Plus,
let's find out, man.
in other parts of the world, it's profit before trees, the land.
Absolutely. I mean, the Amazon is being destroyed because of cattle. I published a figure with my partner a few years ago about the Amazon and the Amazon wildfires. And I obtained by some miracle the data on deforestation and beef exports from the Brazilians themselves.
Really?
Yeah, so it's their own data. And I'll show you what it looks like. So this was published in the Columbia what's it called? State of the Planet, Columbia Climate School. And if you look at, I created this graph. So heads of cattle exported out of Brazil, forest loss. There is almost a one-to-one correlation.
Yeah.
I mean, it's not like, and you know, eating.
I don't know where we move to if the world heats up much more.
You know, I mean, we can always go farther north, but I don't think the Mainers are going to take us. I think Mainers are going to want us to stay where we are.
Yeah.
Also, there are no roads up there. Did you know that?
I've been up there to Jackman and a few other places.
Yeah.
It's pretty rugged up there.
Yeah.
Just
Okay,
way up there.
Yeah. Okay. Thank you all for attending. And Alex,
Thank
once
you
again,
for
thank you so
thank you
much
very much.
for your time and your perspective.
Yeah. Hopefully
Thank you
we'll
very
do
much.
this
It
in
was
person.
Really refreshing, and we hope you continue to do it.
Sure.
good
Hopefully
luck.
be able to, thank you, everyone. Thank you, Vince. Hope to see you sailing soon.
All right. Well, thank you all. Have a good night.